Your application is a major hit in the market because you, being a great developer, did all the market research, targeted the right audience with great user experience and functionalities offered by no one else. Here is how a request response flow looks like. A client will send the request and your server will return back the response. With increasing number of users, your clients are seeing a delay in their request being processed. But you are monitoring all the data, and to offer smooth experience, you upgrade your server. You add more RAM, more CPUs, but that is not enough. So you added more servers with same code base. But how do we know which server can be used for a given request? That's where we need some kind of intelligence which can distribute incoming requests among your server. That intelligence is offered by a load balancer. Load balancers distribute incoming requests to computing resources such as application servers or databases. How does it works? Let's see the flow. So clients will send their request which will be intercepted by load balancer, which will be acting as a dispatcher in this case. It will be connected to a worker pool, which will be a set of workers, which can be your application servers or any other computing resource which can serve the incoming requests. It will pick a worker to forward the request, wait for its response, and once response comes back, it will return back the response to client. How requests are distributed among these workers depends upon load balancing algorithm you can use. It can be simple round robin where, let's say, if you have three servers, first request will go to first server, second request will go to second server, third request will go to third server, fourth request will go to first server. Or it can be more dynamic, which considers number of active connections each worker has, and it can send a request to the worker with least connections. So there are various load balancing algorithms which can be used to distribute incoming requests. So in each case, the load balancer returns the response from computing resource to appropriate client. Each of the worker will share its current state with the load balancer. This way, load balancer can monitor the health of each of these worker. And let's say if any of the worker is not capable of serving requests, then load balancer can prevent requests from going to unhealthy servers. With load balancers, the requests can be distributed among different servers based on their current load. This way, we can avoid overloading our resources. If one of the server goes down, which we discussed, if this server goes down, still the request can be served by the other servers. So this way we eliminate single point of failure in our design because we have multiple servers and load balancer can distribute requests to any of the running server. Additional benefits which load balancer offers is SSL termination, which means it can decrypt incoming requests and encrypt server responses. Backend servers won't have to do these expensive operations. It can also issue cookies and it can send a request from a specific client always to a specific server in case servers do not keep track of sessions. Now, in this design, your load balancer itself can be a single point of failure. To protect against failures, it's common to set up multiple load balancers either in the active passive system or in the active active system. In active mode, both the load balancers are active and they work to handle requests. In one load balancer is active and other by on the standby, and it can take over in case the active one fails. Load balancers can be implemented with hardware which is expensive or with software such as HA proxy. There are layer 4 and layer 7 load balancers as well. They distribute requests based on the payload in the layer 4 and layer 7 in the OSI model respectively. To give an idea about OSI model, the OSI model describes 7 layers that computer system use to communicate over a network. Layer 4 load balancer looks at the info at the transport layer to decide how to distribute requests. Generally, this involves the source, destination IP addresses, and ports in the header, but not the contents of the packet. So these layer 4 load balancers forward network packets to and from upstream servers, and they perform network address translation, also known as NAT. Layer 7 load balancers look at the application layer to distribute the incoming requests. This involves contents of the header, messages, and cookies. This layer 7 load balancer terminate network traffic. It reads the message, makes a load balancing decision, and opens connection to the selected server. For example, a load 7 load balancer can direct video traffic to servers that host videos while directing more sensitive user billing traffic to security hardened servers. Here is an illustration where we have layer 4 load balancers in active passive mode. This is your standby load balancer, and here we have layer 7 load balancers which open connection to your selected application server. That's all about load balancing, like how we can distribute incoming requests among your multiple servers and what are the different type of load balancers and the modes in which we can set up those servers. Hope you have learned something useful from this video.